Alright class, today we will be learning about 6.6c, which we are going to represent a given situation using verbal descriptions, tables, graphs, and equations. Now in 5th grade, you learned how to generate a numerical pattern when given a rule in the form of y equals ax or y equals x plus a, and then graph. 5.4d said you could recognize the difference between additive and multiplicative numerical patterns given in a table or a graph. And 5.8d said you could describe the key attributes of a coordinate plane. And in 6th grade, we've already learned how to identify the independent and dependent quantities from tables and graphs and write an equation that represents the relationship between independent and dependent quantities from a table. All of this will help you learn what we're going to do today. Alright, these are the 4 representations that you will be learning today. You have the verbal description, the equation, table, and graph. You know all what these are separately, but we're going to be learning how to turn one into the other. Now the verbal description is just a summary of the math. It's in your own words how to solve the problem. Now the equation, however, you've already learned. In 5th grade, you learned y equals x plus a and y equals a times x. Those are just the formulas. You're going to plug in what you can from your problem. Now in 6th grade, they changed the variables out, but they're no different. You got y equals x plus b and y equals k times x. It's the same thing. I don't want you to worry about that any further. Now a table, you can see it 2 ways. You're going to see it vertically and you're going to see it horizontally. Now I will have my x and my y. X always is first. And you're going to take anything that's on there. I got 1, 2, 3, and let's pretend that's 4, 5, 6. I'm going to take what's on my table and I could graph those points by using ordered pairs. Your ordered pairs, if you remember from 5th grade, is x, y. And so my first x is 1, my first y is 4. And that is my first ordered pair. I can go on to 2, 5, and 3, 6. Now, if you remember how to graph these, it's very simple. Your x is 1 and your x is always first. So I'm going to go from 1 up to 4. And then 2, 5, 3, 6. Now we're going to do our own problem. I'm going to read a situation and show you how I would get a verbal description, equation, table, and graph. After that, I'm going to put a new problem up on the board and you and your group will work together to create all 4 of these representations. Trey owns X pair of custom shoes. He has 3 more pairs of regular shoes than custom shoes. If Y is the total pairs of shoes Trey owns, represent the situation using a verbal description, table, graph, and equation. Now I recognize that this sentence right here tells me that this is an addition problem. He has 3 more pairs of regular shoes than custom shoes. So I know that I'm going to have to add 3 regular shoes to my custom shoes, or Trey's. So I'm going to say custom shoes plus 3 regular shoes equals the total pairs of shoes Trey owns. Now when I would do that for an equation, I know that this is an addition problem, so I'm going to choose the additive equation. I have y equals x plus b. Well, y equals x plus b. My y is the total amount of shoes Trey owns. And my x is the custom shoes, and I have to add 3 to that. So my equation is going to be y equals x plus 3. And I'm going to take that equation and create a table. That table, I'm just going to go ahead and do it vertically, and my x and y are going to come here. Now, I'm going to go ahead and think of an x. If I have 0, or if Trey has 0 pairs of custom shoes, I still need to add 3, and that's how I'm going to get my y. 0 plus 3 is 3. Now, what about if Trey had 1 pair of custom shoes? Well, if Trey had 1 pair of custom shoes, I'm still going to add 3. So 1 plus 3 is 4, which is my y. And now, the last one, if my x was 2, if I had 2 custom shoes, 2 pairs of custom shoes, I'm going to add 3 to that, and I would now have 5 total pairs of shoes. Now, you're going to take these and you could create coordinate pairs with your graph. Now, your coordinate pairs, or your ordered pairs, look like x, y. And I'm going to have 1, 4, 2, 5, and 3, 6. I get that from my table. My first x is 1, and my first y is 4. So they have the ordered pair 1, 4. Notice that my x is first and my y is second, just like my table. Then I could come around and graph. I know 1 is going to be my x-axis, so I'm going to go over to 1 and then up to 4 and put a point. After that, I'm going to go from 2 on my x-axis and up to 5 on my y and put a point. And then I have 3, 6. And now I have my 4 representations. I have my verbal description, I have an equation, I have a table, and I have a graph. All right, this problem is what you're going to be working on with your groups. I'm going to go ahead and read it, and then you're going to have 3 minutes to work on your whiteboards and create a verbal description, equation, table, and graph. Now, Ray rode his bike every day this summer. He traveled 2 miles every 1 hour, which is x. If y is the total miles traveled, represent the given situation using a verbal description, table, graph, and an equation. Now you have about 3 minutes to finish this. Remember, you're working on your whiteboards, and one of you will be presenting. I will choose a group at random, and you amongst yourselves will need to decide who is going to be talking at your group. Go ahead and get started. You have 3 minutes. All right, now let's pretend it's about 3 minutes later. All right, class, I want to go ahead and talk about what you've come up with. Now, I'm going to roll the dice, and whatever group number I pick, their presentation person needs to stand up and give me the verbal description. All right, I rolled a 3. So group 3, will your presentation person please stand up? All right, Alexis, thank you so much. Now, Alexis, what description did you come up with? All right, you're saying that you're going to take that 2 miles and multiply it by the number of hours. Very good. That's exactly right. You're going to take the miles, you're going to multiply 2 miles by the number of hours spent riding, which is your x. Now, thank you, Alexis. You may sit down. All right, I'm going to roll the dice again. Group 4, go ahead and stand up. Your person that presents, stand up. Isaac, thank you. Isaac, can you give me the equation? Or better yet, can you tell me if this is an additive or multiplicative problem? Yes, it is a multiplicative. And can anybody here, Isaac, don't sit down yet. Can anybody here tell me what the form for a multiplicative equation is? Elizabeth, please. Y equals AX. Well, remember how I said we learned y equals AX last year? It's the same thing, but in 6th grade, we're going to use y equals KX. But very good. Now, Isaac, back to you. What is the equation you came up with? Very good. That's exactly right. You took your y equals kx, used that form, and created your new equation. Y equals 2 times x. That states that your total number of hours spent riding is 2 miles times the number of hours. Good job, Isaac. Thank you. You may sit down. All right. For the table, let's go ahead and I'm going to roll the dice again. Oh, it's table 2 again. Table 2. Somebody not Alexis. I know she was your presenter person, but I need somebody else. Thank you, Allie. Allie, what kind of table did you do? Did you do a vertical or a horizontal? You did a vertical, okay. And what were your 2 variables? You did x and y. Good job. Now, what numbers did you choose? You did 0, 1, 2, and 3. You went to 6. Well, up to 3 is fine for now. Thank you. So how did you get your y? So Allie told us that she plugged in her x's to the equation. That's exactly right, Allie. You said your y is equal to 2 times 0. Well, what is 2 times 0? 0. Good job. What about 1? You plugged it in. Y equals 2 times 1. Well, what's 2 times 1? 2. The next one, we get 4 because 2 times 2 is 4 and 2 times 3 is 6. Thank you, Allie. You may sit down. All right, roll the dice again. Group number 3, stand up. All right, Thomas. How did we graph this? How do we create a graph? Well, very good. You got your ordered pairs first, but that doesn't mean we're done. But we'll go ahead and get that ordered pair from you. What's your first ordered pair? Okay, 1, 2, 2, 4, and 3, 6. Did you not do the 0? Now, that's perfectly fine. Allie and her group did, but we will go ahead and leave that off for now since you didn't. Now we're going to graph it. Very good. How did you graph these points? We're going to go to 1 on what axis? The X. Good job. 1 and then up to 2. And then 2 all the way up to 4. And then 3 all the way up to 6. All right, and now you each have your 4 representations. This is very easy, isn't it, class? Yes, it is. All right, so now let's get into some problems. Now we're going to do an example. Make sure you look at your handout and find this question. It should be the first one, example 1. Derek's favorite game at the fair is basketball. He wants to bring enough money to play the game several times. If each game costs $2.50 to play, which table represents the amount of money Derek might spend playing basketball at the fair? All right, I'm going to give you about 20 seconds for you to figure out what is your X and what is your Y. And I'm not talking about the numbers. I want to know what they represent. So about 20 seconds, and then I'm picking a popsicle stick for somebody to answer. Okay, so let me go ahead and pick a name. Michael, what do you think? Have you come up with something for your X and your Y? So your Y, you think, is how much money they spent. Why do you think that? Well, that's a great thought process because your Y is your answer, and that's what the question is asking. How much money did Derek might spend? That's very good. That's exactly right. Your Y. Now let's see, what about the X? Oliver, what about the X? What do you think the X is? Oh, you think it's how much the games cost. Does anybody have a different answer? Tina, what do you think your X is? How many games he played. Very good. Oliver, if we already know how much the game costs. It says right here it's $2.50. But the X is how much or how many times we're going to play the game. So your X would be number of times played. All right, so now let's create an equation. I want you to talk with your group. I'm going to give you about, about 30 seconds to create an equation. Things to think about: is this a multiplicative equation or an additive equation? Go ahead, you got 30 seconds. Okay, everybody, eyes on me, please. Now, you had 30 seconds to come up with an equation. I'm going to roll the dice, and one person at your group, I'm going to talk right now, figure out who's your presenter. All right, and I'm going to roll the dice, and I want to see that person stand up at that table. All right, group 5, please stand up. All right. Tanya, what equation did y'all come up with? Did you think it's an additive or a multiplicative? You picked a multiplicative. Very good. And what equation did you present? Or did you write down? Okay, you did y equals k times x. Very good. That's the form. That's like the formula you should use. But is that the equation matching the word problem? Oh, no, yeah, you get it. Okay, so what would I put instead? Y equals, good job. Yeah, that $2.50 times x. That is saying we're going to multiply $2.50 times the number of games played, and that is going to equal the money spent. Good job. So now let's solve. Here is our formula, our equation. And now let's figure out which one could it be. First of all, if x is the number of games he played, I want you to look at all of your x's. What do you see that could be a problem? About 10 seconds, and then I'm going to pick somebody. Okay. Luke, what do you think? Look at your x's. Tell me, what do we notice? Well, yeah, the A and B have decimals, and the C and D are whole numbers. Well, can you play half a game? Do you pay for half a game? No, you pay for a whole game. So we could go ahead and exit those out, eliminate them. We don't need them. So now let's look at C and D. For C and D, we have whole numbers the whole way, but let's look at the first ones, 0, 0. Both x's are 0. But one x is 0, the y is 0. If we were to plug that into our equation, 0 equals $2.50 times 0. Is that true? What is $2.50 times 0? Very good, it's 0. Anything times 0 is 0. So does 0 equal 0? Yes. So that's true on both ones. What about the next one? What can we do to figure out if that's true? Yes, you plug in your equation. Good job. We got our y is $2.50 equals 250 times 1. Well, what's $2.50 times 1? It's $2.50. Yeah, we're only multiplying by 1. Anything times 1 is itself. So is this true? Yes. So the next ones on both are true. Well, let's try the third one on C. We're going to plug it in. $5.50 is equal to $2.50 times 2. Right now on your boards, I want you to solve this. What is $2.50 times 2? Anna? Very good, it's $5. Is $5.50 equal to $5? No. So the third one is incorrect. Well, let's try the fourth one. We're multiplying by $2.50. So what is 5? I'm going to go ahead and make room. This was wrong, everything else was right. What is 5 times 250? Work that out right now. I will too. 5 times 5 is 25. 5 times 2 is 10 plus 2, 12. One place value after the decimal, so I'm going to have one place value after the decimal here. So my answer would be or 10 equals 12.5. Is that true, guys? No. So C is not the correct answer. That leaves us D, but we want to make sure. So we already know that 0, 0 is correct and 1, $2.50 is correct. Let's check and see if 4, $10 is. So our equation was y equals $2.50 times x. So let's plug it in. We got 10 equals $2.50 times 4. So go ahead and solve that right now. All right, Liam, what did you get? 2 5/10 times 4 is what?
I'm afraid I can't answer that.
10, very good. Does 10 equal 10? Yeah. So the third one's correct. And let's try the fourth one. So y equals 2 5/10 times x. So we would plug in our y, 1750 equals to $2.50 times, in this case, 7. So I want you to work on this right now. All right, Lisa, what'd you get? Yes, $2.50 times 7, or 2.5 times 7, is 17.5. But isn't that the same thing as $17.50? Yes, it is. So my answer is D. Good job, everybody. I want us to move on to example number 2 now. Felipe pays $4.20 per carton for fresh eggs from the farmer's market. If X represents the number of egg cartons and Y is the total cost, which of the following representations contain an error? All right. Look at your problem. Then look at your answer choices. What do you notice about your answer choices that are different from the other problems we worked on? Carla, yes ma'am. Very good. They're all in a different form. Okay. Yes, they're all in different, they're one of the 4 representations we saw. That's exactly right. Good job, Carla. So now we're going to have to make sure that the problem matches each of these representations. So first let's do the verbal. Or no, let's do the equation. I'm going to give you about 20 seconds to read the problem and come up with an equation. All right, Leilani, just pulled your popsicle stick. Is this an additive or multiplicative word problem? Very good, it's multiplicative. We're multiplying here, aren't we? We're looking for the total cost, and X represents the number of eggs, or egg cartons. Very good, it's multiplicative. So what equation did you come up with? You got Y equals $4.20 times X. Exactly right. Good job, Leilani. Now, Alexis, is that the same thing as the first answer choice? Yes, it is. Good job. It looks different because it's $4.20, but does that zero really matter? Well, yes, if it's money, but not if we just want to put it to the tenths place value, we can. Very good. 4.2 or 4 2/10 times X. So F is correct. We're looking for the one that contains an error. So the one that's not true. All right, for a table, notice that this is a horizontal table. How do we figure out if this table is correct or not? Tina? Very good. You're going to plug your answer, your X and Y in there. So for Y, what is your first Y? $4.20. Is that equal to $4.20 times 1? Yes, it is. Good job. So the first one is good. How about the second one? 3 and 12/60. What do we need to do? Very good. You plug it in. So we have $12.60 equal to $4.20 times 3. So we have to make sure that $4.20 times 3 equals $12.60. Let's do that to the side. Please remember that you have one place value after the decimal, so you have to have one place value after the decimal in your answer. So I got 12 and 6/10, or $12.60. Is that true? Good job, that's correct. Now let's try the last one. We have $16.80 is equal to $4.20 times 4. Let's go ahead and work that out. $4.20 times 4. All right, work this out. I'm going to give you about 15 seconds. All right, good job. I'm going to pick a popsicle stick and I want you to tell me your answer you got. Carlos, what do you get? You got 1680. Where's my decimal in this? Very good. In between the 6 and the 8, I have 2 place values after the decimal, so I have to have 2 place values after the decimal in the answer. So $16.80, which is correct in this table. So G is correct. We need something that has an error. What about H? Let's look at H. The value of Y is 21 over 5, which is a division problem because a fraction is the same thing as a division, times the value of X. Well, what are we multiplying by X here? That's right, $4.20. Good job. So we have to figure out what that fraction is. How do I turn a fraction into a decimal? Let me get a popsicle stick. Amelia. Yeah, you used Tybo. Good job. You're going to divide the numerator and the denominator. Which one goes inside? 21. Good job. Top in, bottom out. 5 goes into 21 how many times, guys? 4. Good job. 4 times 5 is 20. Bring my remainder down. Am I going to create a fraction here, a mixed number, or am I going to keep going as a decimal? As a decimal, what do I need to add right now? Very good. A decimal and a 0. Let's bring that 0 down. 5 goes into 10 how many times? 2. Good job. 2 times 5 is 10, and I have a remainder of 0. So my answer to 21 divided by 5 is 4 2/10. Is that the same as $4.20? Yes, it is. So is H correct? Yes, it is. That's exactly right. So let's look at our graph. We know, and we already have a correct table, so we could look at that table. We know that our X is 1 and our Y is $4.20. But here we have 1 as our X and Y is 4. Is that correct? No, it's not correct. That should have been $4.20. So J is our answer because it's the one that contains an error. Good job, class. All right, now we're going to check and see if you understand this. So I want you to create a word problem that represents one of the following equations. Then you're going to choose one other way to represent your word problem and equation. So you have either y equals x plus 5 or y equals 5x. Now you're going to turn those into a word problem of your choice. It could be anything. And then choose one other representation. That can mean a table, graph, or verbal description. You already have the equation. After that, I'm going to be choosing one person in your group to present. Now, everybody, I want you to think about what you're going to be doing and get started. Let me give you about 7 minutes to do this. That should be plenty of time. All right, get to work. All right, so now here, I would be monitoring the classroom, going around, checking and seeing which students are working and which ones aren't, and those that aren't, kind of making a note, because the reason they could not be working is because they don't understand what they're supposed to be doing, and I would go over there and talk to them and kind of guide them through it a little bit. Now, once everybody's completed, I'm going to go ahead and have randomization, pick which ones present. Then I will be gathering data as I walk around also and kind of seeing who's getting it, who's not. And once they're done with their presentations, I would move on to more practice time. I would usually move on to stations, but I would still pull the ones that don't understand, the ones that are not getting it, as my first teacher station or my first small group. Once the class is done, I will be moving on to an exit ticket. Now, this problem is just one that I chose, but could be any one that assesses what you went over today. Here they're just assessing if they could create an equation from a word problem. Now I will be putting this word problem on Schoology to where I could get real-time data, like I'll be able to understand who gets it and who doesn't by the class is over. And once that happens, I could make a list of those who don't get it and pull them for a small group the next day. And the ones that do get it, plan some kind of extension or have them move on to something else.